Morning, doctor.
Yeah, morning. Hope you guys are doing good. Okay, so we'll resume our lecture. Um, so previously what we have covered, we are still in LU2 for your information, right? Just to recap what we have covered before, LU1 we talked about introduction, basically just some basics in statistics, yeah, right? And then in LU2 we start discussing about non-parametric tests, where the first test that we discussed last 2 weeks, I guess, yeah, was sign test. Yeah, is the first test that we discussed and is the simplest test. Okay, and after that we talk about Wilcoxon sign rank test. Yeah, the second test that we took is also a non-parametric test. And today we are going to look at the third test, the third non-parametric test, which is called Mann Whitney rank sum test. Okay, but before that, let me just recap with you the first two tests that we have took before, right? So what is actually the difference? I can say Wilcoxon sign rank test is actually an advanced form of sign text, whereby it takes into consideration the magnitudes when comparing. Okay, firstly, the bottom line of any statistical test is to compare sets of data. Okay, so in sign test and Wilcoxon sign rank test, yeah, even before that, sign test only talks about comparison in terms of the signs. Okay, signs, S-I-G-N. Yeah? So it doesn't take into account how much. Okay, regardless whether it's +1 or +9, the difference is considered as positive. Okay, so the downside of it, even though it's a simple test, it doesn't give us a very strong conclusion at the end, actually. Yeah, because at the end of the test, we want to conclude whether whether the sets of data that we compare, are they the same or are they different? That is actually the bottom line of any statistical test. We want to compare and want to make conclusions at the end, right? And of course, we hypothesize, where the hypothesis, there are two hypotheses, null and alternative, right? So I hope you remember now what's the null and alternative, right? But that is basically the any test is. Eh? So the Wilcoxon sign rank test, it is called an advanced form of sign test because it takes into consideration the magnitude. For example, the magnitude is the value of difference. Okay, let's say 75 and 70, the difference is 5. The magnitude is 5. Okay, so if you see from the point of view of 75, it's +5 more. Yeah, it's more by 5. So that 5, the value of 5, example, that is magnitude. Okay, so whenever we compare based on the magnitudes and also the plus, of course, when we talk about magnitudes, it's also considers the signs. It gives a much stronger conclusion at the end. Yeah, when you say it is different by what? By how much? I mean, it's based on by taking into consideration uh, the level of the difference, little or less or high, yeah? Low or high, the value of difference. So that's why Wilcoxon sign rank test is considered as a stronger test than sign test. Okay. The similarity of the data for these two tests are used for comparing sets of data that are related, For example, if you are talking about one sample, right? You can see from the examples given, right? You said that you test a sample of students, you give them maybe a course and then you evaluate their score for the exam before they are given, let's say, a course, maybe training something, and then you evaluate their scores before, and if you evaluate again the same sample after the training is given to them. So it's to see whether or not the course is beneficial in enhancing the score. Okay, so but the data, you can see that the data are matched, the data are related, we call it. So if you see the definition of the test, to test pairs of the pairs of observations, the weights of subject before and after, right? But in short, they are related, they are dependent. Okay, if you see for the Wilkinson sign rank test, the definition of the test is also for comparing two related samples, the samples that are associated, that are matched, matched sample, repeated measurement of a single sample. So those are related, okay? So that is the types of data that the types of data that require Wilkinson sign rank test or sign test. Okay, now if let's say one of your friends asks me in the Telegram, right? If let's say the question, you can let's say the question, okay, I think it's one of the examples, right, in the lecture notes. So that data, can I have a look at it again, please? I think it's an example past here. Okay, this one. So this is an example in Wilkinson sign rank test. 8 properties are assessed by 2 registered evaluators. The problem is to find out whether evaluator X gives higher evaluation than evaluator Y. The evaluations are given in the following table. So you can see that these data, they are matched to each other and they are to be compared. Okay, so by nature, if you see this kind of problem, you can also use sign test. If it is not stated specifically that you have to use the Wilkinson sign rank test, actually you can also use sign test. Okay, but as I said just now, the conclusions drawn from using sign test could be similar or could not be similar to Wilkinson sign rank test because of the nature of the test. The test is different, okay? Because the nature of the sign test, it just evaluates the signs. The Wilkinson sign rank test, it considers both sign and magnitude, which means that it is much stronger. So maybe some of the things analyzed by the sign test, it could have some inaccuracy, because of the nature of the test is not so comprehensive. So it could give a little different conclusion compared to the Wilkinson sign rank test. So, but if you are lucky, maybe you get the same conclusion, but it could also be not similar. Okay. But the nature of this data, it can be actually analyzed by sign test or Wilkinson sign rank test because they are actually dependent data. Okay. Okay, I forgot what I want to say just now. Okay, back to that one is Wilkinson sign rank test. Okay, back to today's lecture. What is our focus today? We move to the third test, which is called Mann-Whitney rank sum test. Okay, so this is a bit different because the data, the type of the data that we are going to deal with is different from the previous two data. Okay, So by definition, if you see the information that I put on ellipse here, it is also called Mann-Whitney U test. Okay, that is another name for it. So you should know that sometimes it's U test, sometimes it's Mann-Whitney rank sum test. It's still a non-parametric test. So when we say non-parametric, remember the data, there are many possibilities of the data. One of them is the data, the size of the data is small, which is less than 25. So that's why you can see in the problems or examples given, you can see that the sample size is very small. It's actually less than 25. Okay, so that kind of data is considered as non-parametric. Whereas if it is more than 25, it is considered as parametric, which we will cover in LU3. Okay. Another example is whether it can be ordinal data or nominal data. Remember, ordinal is referring to the data that deals with the order. Yeah? Like, for example, the ratings of restaurant, for example. Okay? We give like ratings from 1 to 5. So how many votes 1, how many votes 2, and so on. Okay, that kind of data is ordinal, we call it. And also another one is nominal. Nominal is referring to certain qualities. For example, color of car. The color of the car is red, blue, yellow, black. Okay, that is nominal. It's by different category. Okay, different feature. That is a type of nominal. Okay, so that any of that, if let's say the data falls into that sort of category, it is called non-parametric data. Okay, and even if let's say the data are not ordinal or are not nominal, if let's say the sample size is small, which is less than 25, it is called non-parametric data. Okay, so means non-parametric data. How to analyze them? We use all these non-parametric tests. So in order for you to know which non-parametric test is suitable, you have to understand every test first. So that's why we teach you different tests, okay, under LU2, under non-parametric test. Okay, so the third test is Mann-Whitney rank sum test. So what is the difference between this test and the other two tests? It is used for analyzing two independent samples of non-parametric data. We are still talking about non-parametric data, but take note on the terms there, in the two independent samples. So before this, for the sign test and the Wilkinson sign test, the type of data is dependent data, dependent samples. You know what the word dependent, independent, right? Dependent means it's related, associated. It has to be based on the other thing, the other sample, or the other set of data. Whereas when we talk about independent samples has no association. I mean, yeah, they come from different sources, you know, but you want to analyze them, so you need this test. Okay, I hope that's clear, because that will be the difference between this test and the other two tests. And that is the basis for you when you see the set of data, if let's say it is not stated in the question, or even if let's say later after you finish this course and you are doing research and you have sets of data, you have to analyze by yourself whether these data are independent, this, you know, the data that you want to compare, are they dependent, are they independent? So that will be the basis for you to select which test you want to use in order to analyze the data. Okay, right, let's have a look at the lecture. Okay. Mann, Whitney ranks some tests. So we are going to look at some definition of it, and the core part will be how to use the test. Okay. So actually, in every test, we are concerned with how to use the test actually. Okay, what are the steps that need to be taken? So you can see the similarity from one test to another. The first and the last point or step will be the same, whereby we develop the hypothesis, and at the end we make decision, right? And we make a conclusion. But the difference is how the test is conducted, how we analyze the data, and every test, it has its own rules of thumb. It has its own principles. Yeah. And the way how the tests, they are actually developed by statisticians before, and they believe, this is, based on their research observations. So that's why they created certain parameters. Yeah? So every test, it has its own test statistics, things that we need to find out, the tables, okay, to refer to, and that has been invented before by them. Okay, so they have developed this kind of test. So our role is to understand, the application of it, how to use it, right, and the relevance of it. Yeah? Right. So Mann Whitney ranks some tests, as I said just now. It is used to compare. Okay, so in statistics, we always want to compare. Okay, that is our business for statistics. We want to use statistics to compare. So why we want to compare is because we want to make a conclusion. At the end, whatever the things that we compare, is there any difference? Is there significant difference? How much the difference? That is actually the idea. Okay. So if you see, even if you think something very simple, like if let's say you want to do a very common research about uh, about 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 trend of spending, trend of internet browsing, okay, in terms of how many hours. So you want to compare, let's say, in the state of Selangor and in Johor, let's say, the trend of people spend on internet. Okay, so yeah, of course, it's about, let's say, just to these two states. You are comparing apa tadi, Selangor and whatever lah, Johor, let's say, the trend of internet browsing, the number of hours people spend on internet. At the end, you want to conclude that whether is there any difference between Selangorian and Johorians in terms of their trend of spending internet. Okay, so you want to reach that sort of conclusion, right? So in order to reach that conclusion, you have to analyze the data. So that is actually the core business of this course. We want to know what are the tests that can be used to analyze the data. And of course, the data, it comes in different forms. Some of them are dependent, some of them are independent. Okay, so those things that you have to take note, okay, when we talk about the types of data. And we are always concerned with samples, as I said in the previous lectures. Why samples? Is because samples will represent the picture about the population, right? You are analyzing the data from states, 14 states in Malaysia, in order to describe Malaysia. Malaysia is a population. We cannot analyze every single person in Malaysia. So we have to take just some samples to represent people from Selangor, people from Johor, Kedah, Penang. Yeah? That is the sample. So that's why we are talking about samples. Okay. Now, what is meant by independent sample, as I said just now? So this test is used for two small independent random samples. So now, if you see, even before this, we are just dealing with two samples. So after this, we are going to deal with more than two samples. Okay, so these are actually, we are going from the simplest test to the most complicated. So that's why you can see that previously also we just talked about 2 samples, but there are tests for analyzing more than 2 samples. Okay. Right, independent samples. Okay, this test is used to analyze 2 small independent random samples from whether they are from identical populations. Okay, so now you see the word small over here. So that's why it is non-parametric. As I said just now, when the size is less than 25. When it is more than 25, you cannot use non-parametric tests. You have to move to parametric tests, which we'll cover in LU3. Okay. So we used to examine the null hypothesis that there is no true difference between the 2 populations based on data from 2 independent random samples. Okay, so say suppose we have 2 samples, yeah, sample 1 and sample 2, and they are independent. Independent means they are not associated. They are not like before and after treatment, something like that. You know, it's something like just random. It just stands by itself. Okay, you collected the samples from, for example, just now from Johor, and then you collected samples from this area. So that they are independent. Okay. Yeah, so we want to compare these 2 random samples, independent samples, and whether and to see whether there is a difference or not. Yeah, the same thing, whether there is a difference or not between the 2 samples. Okay, so that is actually what Mann Whitney rank sum test is all about. And it's also called U-test. Okay, it's an alternative to the unpaired t-test or 2 sample independent t-test. Okay, so t-test will be covered in parametric test. It is a very popular test actually. Yeah. So if you read articles, there are so many, actually most of the analysis will be based on parametric tests. So t-test is one of them. And for the parametric data, we also have a condition where we analyze 2 independent samples. So that's why it says here that, you know, if we want to compare with the parametric data, it is equivalent to 2 sample independent t-tests. Okay. Mann-Whitney rank sum test does not assume that the 2 population sample have normal distribution. Okay, this is another criteria of non-parametric data, whereby we do not know actually what's the distribution, how the distribution looks like. Distribution is how the data looks like, whether it is, you know, is normal or it is not normal. Okay. 2 independent samples are taken from the same kind of population distribution with a possible difference in the means. Okay, so this is right. So how we construct the hypothesis of Mann-Whitney rank sum test. So you have to understand the nature of the samples or the data that you want to compare. Okay, now we are talking about 2 samples, right? So this one is not really different from previously. So we just assign, because we are concerned with mu, the mean, yeah, the mean of the first sample and the mean of the second sample. We denote is 1, 2, or AB. Okay, so the null hypothesis will say that there is no difference in the mean between the 2 samples, or mu1 is equal to mu2, or you can also say mu1 minus mu2 is equal to 0. It's also the same. Okay, but the basic, the bottom line is that there is no difference between the 2 samples in terms of the average. Okay, so if you write the alternative hypothesis, it should be, it can be in general form, it can be it's not equal, but this one can also be mu1 greater than mu2 or mu2 greater than mu1. Okay, so how you construct this, whether this is 2-sided and this is 1-sided or 1-tailed. Okay, this is 2-tailed, 1-tailed. So it depends on the questions. It depends on because the question will state the focus, okay? Whether you want to test which one is bigger, or if it's not stated, if let's say it states that test whether there is a difference between the two samples. So it sounds generic. We don't know. I mean, we don't specify which one is bigger than which. So you can use the first, this one of the two-sided case situation. Okay. So that's how you construct the alternative hypothesis. Okay. So the procedure for the test, the first one is the hypothesis. Okay, we're done with that. Okay, another one is alpha. So alpha is the significance level, right? It is a predetermined value that we assign. As I said, it is like the probability of error. Okay, that is alpha. So the normal value chosen is 0.05, or it can be 0.01, but normally it's 0.05. And the reason why 0.05 is a value that has been chosen by statistician because they have observed, right, they have done many observations and found out that, the relevant value or the average value is 0.05. Okay, so which is 5%. Meaning to say that if I want to define it, this one is the percentage of error, percentage of, let's say, the accuracy of the whole data. You cannot expect it to be totally accurate, right? In anything, there is nothing entirely accurate. So there must be rooms of errors, inaccuracy, because nothing is perfect in this world. So this is actually represented by this alpha value, okay? So if let's say we want to analyze our data, let's say we have a set of data. So we can just set, just allow some room of errors. We say that 5% is error, and 5% is error. So that makes that the data is not entirely not entirely correct. I hope you get the points or the meaning of this alpha. And this alpha is predetermined. Means that we are the one who set it. And the value that we set, of course, we have to be based on the values that have been set by statisticians before, because they have done all the observations. And 5% is the common value chosen for the error. Okay, right. So this one is you have to set it. If let's say it is not given, you have to set it by yourself. You have to define it. Okay, and then the second step is combine the two samples. You just go through first the steps, and later we go through the example. Okay, combine the two samples, and then we have to rank the combined samples, right? So what is rank? You know what ranks? So whenever we rank the samples, we assign the order from the lowest to the highest. Okay. And also these tied ranks. Okay, this one is also, you have to take note. What is meant by type ranks is, let me show later. I think now, if I give it now, maybe it's not that really clear. Okay, if let's say I give later I'll show what type rank is. It is actually when you have to rank something, but it has two values or more than one value are the same. So you have to actually find the type ranks, or the rank that is similar for all the numbers that are similar. Okay. Rank the combined samples, and then the fourth step is to calculate the sum of ranks of sample 1. We denote it as S1. Okay. Sum of ranks of sample 2. I'll show later. Just go through first, and then the thing that we need to calculate in this test is U. That's why it's called U test. So we have to find what is U1 and U2. This is the formula given. It will be given in the exam. It's just that you should know by yourself how to use it. Okay, so U1 is equal to S1. So that's why you need to find the S1 first. N1 is the sample size of sample 1. The size of sample 1. Okay, and this is the formula. And U2, we just substitute S2 and N2. Okay, so the formula looks the same, but it's just that you substitute S and N accordingly. Okay, so that is U1 and U2. Then in the sixth step, you have to determine the value of U. Just now we talked about U1, U2, and you have to determine what's the U value. So how you determine the U value? There are three conditions. It depends on the alternative hypothesis that you set. Okay, so that's why your alternative hypothesis should be you should make sure it is correct. Okay, otherwise, if let's say you set it wrongly, then you will get for wrong U value. So in the first case, if the test is to tell, yeah, so where you set the mu1 is not equal to mu2, so U will be equal to the minimum value between U1 and U2. Okay, so I've mentioned what this function is all about, right? Mean U1, U2 means that if let's say your U1 is 3, U2 is 5, so the minimum value of U1, U2, which is minimum of 3 and 5, you choose minimum value or the lowest value, which is 3. Okay, so in this case, it's 3. So that's how you determine U, okay, for two-sided test. But if let's say your alternative hypothesis is one-sided, okay, let's say mu1 is less than mu2, okay, so you should go for U1 as the U value. And if let's say U2 is less than U1, you should go for U2 value. Okay, so that's how you determine the U value. Right, the next thing, the seventh step is you have to find the critical value from Mann Whitney test table. So there is also a table for this test. And what you have to find from the table is the CV, yeah? The CV value. CV value, where's the this is a table. Okay, so I have uploaded on Elite as well, if you can see later, but I just want to introduce 4 different conditions of the table. Okay, so if you see the first one here, A, this one is A. This subtable is used for one-sided test at alpha equal to 0.05, or two-sided test when alpha is 0.1. Okay, there are 2 conditions that you can use the first table over here. This is the conditions. It's either one. Okay, if let's say your case is one-sided test and your alpha is 0.05, so you have to use this lah. But if let's say your alpha, you set it at 0.01, which is also possible for alpha value. Okay, as I said just now, it can be 1%, it can be 5%. Okay, so you cannot refer to the first table. You have to refer to the C over here, the table in C, which states that it is for one-sided and alpha 0.01. Okay. So if so you have to see the conditions over here. Each of these 4 tables has different conditions. The first here, the second is one-sided test, alpha 0.025. Okay. So 0.025 is not really common. The most common one are 0.05, alpha 0.05, and 0.01. Okay, but these are what they have prepared, the previous statisticians that have prepared the table. So let's have a look at how to use the table. So you have to know what is N1. This is N1. This is N2. The size of the sample 1 and the size of the sample 2. Okay. So that will be the basis of your search, whereby the values of given here inside here, all these values, these are all the CV, the critical values that you are looking for. Okay. So this is the value of CV that you have to look for in the 7th step. Okay, that's how you use the Mann Whitney U test template. And then after you have determined U, after you have determined CV, you have to compare the U and CV. Yeah? So the decision rule is based on this basis. So if the U value is less than CV, then you have to reject the null hypothesis. Okay, so and the other way around. If it is greater, then you have to accept the null hypothesis. So this is the rule of thumb of comparison. And at the end, you have to make a conclusion. So if you make the conclusion, you have to be specific. You have to go back to the problem. You cannot say, you cannot just end up with accept null hypothesis, because, you know, I don't know what I mean, you have to state back what is meant by the null hypothesis in any case that you're analyzing. So you have to go back to the parameter mentioned in the problem. Okay, so that is the conclusion. And also it's very important for you to mention at in your conclusion, let's say at 5% significance level. Okay, there is no, maybe there is no difference between, if let's say you accept the null hypothesis, there is no difference between sample A and B. Okay, so that this is the example of conclusion. But you must make sure that you mention this, because this is the basis of your comparison. It's based on the assumption that the alpha is 5%, the error is 5%. Okay, so that is that are all the steps for Mann-Whitney rank sum test. So you should know how to apply it. Okay, let's have a look at one example over here. The bacteria counts per unit volume are obtained for two types of culture, A and B. It is of interest to determine whether one culture has a significant count than the other. Okay, so you can see here whether one culture has a significant count than the other. It doesn't mention specifically A is greater than B or B is greater than A. So in this case, this is actually a hint that your alternative hypothesis should be A not equal to B. Okay, because you do not know, yeah, it's not stated which one is bigger or not. So this one should be A and B. Or X, Y, right. Use 5% level of significance. So this is the alpha value. Okay. So these are the data given to you. Actually, the question will be like this only. So this is the one that you have to, this one is actually the solution. The solution. So this is example of the data given to you, or question given to you. So you can see that culture A and B, the sample size is very small, right? There are only 4. 4. N is equal to, and A is equal to 4, and B equal to 4. So this is actually it matched with the non-parametric characteristics, where the sample size is small, less than 25. Okay, so how to analyze it? So the moment you see this data, is culture A and culture B. So you can see that they are from independent samples. They are actually independent samples. So that's the hint also how you can know what kind of test that to be used. Yeah, so in this case it's Mann-Whitney test. Okay, so the procedure to do the test, the first step is to develop the hypothesis, right? So this is the null hypothesis. This is the alternative hypothesis. Yeah, I hope that's clear. And then, okay, now we have to combine, okay, let's have a look at the steps. We have to combine the two samples, and we have to rank the combined samples and use type rank if necessary, if it is needed. It's not actually in all cases we need type ranks. Okay, let's have a look at the data. So we combine the data means that when you rank, you just combine data A and B, right? Okay, if let's say you see from here, what is the smallest value? 26, right? Okay, so 26 is the smallest value. So this will be, we will rank it as 1, actually. So when we say rank, we put the number of the rank, the order from the lowest to the highest. Okay, the second one is 27, right? So this is going to be number 2, rank number 2. Number 3 is 28 because we combine both of them. So that's why what that is meant by combine the samples. So this is going to be number 3 because it's the third lowest. Yeah. Number 4. Sorry, you guys don't correct me. 25 is the lowest. Why you are so quiet? I'm wrong. Please correct me if let's say you see I'm, if there is something wrong with my calculation whatsoever. Okay, this one is number 1. This is number 2. Okay, number 3. Correct? 4.
Correct.
5, 6, 7, and 8. Yeah. So that's how you rank it. You combine both of the samples and you assign the rank. So in this case, we don't have to assign type ranks because all the values are not similar. Yeah. So when they are similar values, let's say they are 26. They are 226. Let's say, yeah. I hope you already know about the type ranks. If let's say you this 26 supposed to be 3 and 4 in terms of the ranks, yeah. So you cannot put this one 3 and this one 4 because both of them are similar in values. So how you determine the type ranks is that you find the average of the third and the fourth rank and divide it into 2. So that's going to be 3.5. So instead of assigning rank number 3 and rank number 4 to these two similar values, you assign both of them with 3.5. 3.5. So this is called type ranks. Okay, I hope you know what it is. But in this problem, we don't have it because all of them the values are not equal. They are unique. Yeah? Okay, so this is type ranks. Okay, just for your information. You will apply it in other problems that have similar values. Okay, so we have assigned the ranks, but if let's say in your workout, you have to be more organized because you need to make sure that you don't do any mistakes. So the easiest way is you put it in this kind of table, right? The ranks are here, 25, 26, 27, which is actually the same as what I did just now, right? But it differentiates the samples, right? So this one belongs to sample A, this one belongs to sample B. And those are the ranks. Okay, so now the next thing that we have to find out is the sum of ranks. What is meant by the sum of ranks? Now we talk about sum of ranks of sample 1, which is A actually. Yeah. So if you see the data for sample 1 and sample A, so these are the data and these are their ranks, right? So you have to sum the ranks of those data of the sample A. So which is 1 plus 2 plus 1 plus 2 plus 3 plus 6. So that's 12. Okay. And the sum of ranks of sample B, you go for here, 4, 5, 7, and 8. Yeah, 4, 5, 7, 8. The sum is 24. And N1 and N2, the sample size, how many data in the sample. For sample A is 4 and sample 2 is 4. Okay, so those are the values that you have to find out. Okay, the next one is to calculate U, U1, U2. So this one is step number 5. Calculate the U. Calculate the U. So you know already the S1 and S2 values. So put it into the formula. The formula is given here. It's the formula. Okay. S1 the formula is S1 equal to S7. U1 S1 minus N1 and 1 plus 1, isn't it? Divided by 2, yeah, it's divided. Okay, so that is the formula. So the same thing for the U2 lah. U2 is S2 minus and 2 and 2 plus 1 divided by 2. Okay, so you just substitute the value of S1 and S2, N1 and 2, yeah, accordingly. So you got U1 as 2 and U2 as 14. Okay, now next you have to find what's the U value. So since this one is two-sided, based on your alternative hypothesis, so you have to refer to this, right? So this is the case for the problem. So U is equal to minimum of U1 and U2. Okay, you got the U1 and U2 minimum. So this one is actually can be written as minimum 2 and 14. So between 2 and 14, which one is the lowest or the minimum value? It's 2, right? So that's how you got the U value. Then the next thing is to find the CV from the table. The CV stands for critical value from the Mann-Whitney rank sum test table. Okay, so we know that N1 is 4, N2 is 4, and our alpha is 0.05. So that's why it's very important for you to take note the value of alpha, because that will determine which table you will use in the this one, Mann-Whitney rank sum test. Okay, so it's two-sided test, right? Our case is two-sided test. Remember, it's not one-sided. And the alpha is 0.05. So actually it falls. Okay, can you guys see the table? So our condition is here actually. Two-sided test, alpha equal to 0.05. Okay. So the n is just now is 4. Okay, how to find the value of the CV? N1 is 4, N2 is 4. So you go here. So the value is 0. The CV is 0. Okay, so that is the value of CV. Okay, go back here. Okay, now CV is 0 and U is 2. Okay, so since U is greater than CV, so we accept the null hypothesis, because the rule of decision is this one, right? We reject the null hypothesis if U is less than the CV. Yeah? So, but our U is greater than the CV, so we accept the null hypothesis. So accept the null hypothesis. So that is the decision, not yet the conclusion. Accept the null. So the last step is to make a conclusion. So we can conclude that at 5% level of significance, there is no evidence of a difference in means. You can say also there is no difference between the mean of sample A and sample B. Okay, there are various ways how you write it, but this is one of the way. There is no evidence of the difference, means that there is no difference actually. Okay, so that is the conclusion. Okay, any questions so far? It's quite easy, right? Actually, you just have to take note on things that you are looking for, the U, the CV, and also how to use the table. Okay.
Excuse me, doctor, may I ask?
Yes.
May I ask how the U value correlates to the table? I'm sorry, I didn't quite catch how that worked.
The U value is Sorry, wait. No, you have to compare the U and the CV value. You don't have to use the U value in order to find the CV value. The CV depends on the sample size.
So the CV is based on the sample size, and
Yes.
I mean, based on my understanding, you get it from the table, right? The
Yeah.
U-test table.
Yes.
May I ask how I use the table again? Because I don't really get it. I'm sorry.
Oh, okay. Can you see the table, the slide here? Is it here? Can you see the conditions given for every table? There are 4 tables over here. There are 4 situations actually.
All right.
Right. So this is the conditions for every table. So you have to find, you have to actually look for what condition that match your problems. Okay. So for
Okay.
example, in the first table here, A, this table is used for one-sided tests when alpha equal to 0.05, or or for two-sided tests when alpha equal to 0.1. So that is the case for this table. But our problem just now, we have two-sided tests, right? Two-sided is because of the alternative hypothesis is not equal. Remember?
All right.
Okay. So the alpha value that we use is 0.05. So this is actually our situation, our condition. Two-sided test, 0.05 alpha. So that's why we use this one, not the rest.
May I ask where do we get the number 4? That
Number 4.
the N.
Oh, okay. If you see the sample, the question again. Wait, where is the question? Okay, the question here. This is given to you up to this information is given to you as a problem, as a question. Okay, so if you see here, this is the sample A and sample B, right? So the sample size for A is 1, 2, 3, 4. So that's why you got N. N is the sample size, and A is 4, and B is also 4. Okay, because of this one, 1, 2, 3, 4. Each of the sample has 4 data, 4 points. Clear?
All right. Thank you,
Okay.
doctor.
All right. So that is N. So also you have to make sure your N is correct, because otherwise you would refer to the wrong values in the table. Okay, any more questions? No?
Doctor, so the U value is not related to the table. It's only
Yes.
using it to compare to the table, but we don't use the U value to go and get the data from the table.
No, but later we use it to compare the CV that we got from the table. Got
I
it?
see. It's two separate things.
Yes.
Okay. Thank you, doctor.
All right. Okay, let's have a look at example 2, right? So the question is to test if the yield or harvest for organic farming is different from conventional farming. Okay, so organic farming is denoted as method A. So before you analyze the problems, just understand the nature of the problems is very important as well. Because when you understand what you are comparing, then you know what you are looking for. For example, if let's say in the case of sometimes the question asks you are like the sample is given a cost, like I think it's one of the examples before. So it's a cost, and the score of the samples, the students, or maybe a group of staff or something, they are evaluated based on their performance before and after they take a course. So the question asks, test if let's say the course is able to improve the performance of the students, something like that. So if you understand the problem, the problem is about like comparing the performance before and after. So that word, it is not stated directly that the test whether the post-course score is better than the pre-course score. It's not stated like that, but it just says that a test whether the course give a benefit, something like that. Okay, so that's why you have to understand the nature of the problem. What is actually, what are the things that you are comparing? In that case, it's about the score. So of course, if it says like that, it implies that you have to test the post-course score should be bigger than whether it's bigger or not than the pre-course score. Okay, I hope you got what I mean. But here you have to understand in that particular problem. It's not that really difficult for you to understand. Like this one, it says that they are comparing organic and conventional farming. Okay, so there are two different methods that require you to compare. So in terms of what? In terms of yield of green beans. Yeah? So the problem is not that really hard for you to understand, but you just have to delve into it. You just have to, you have to understand what the problem is all about. You have to understand the story of it, okay? So that it makes sense for you if you want to compare. Huh? Okay, so it's about comparing the two methods, A and B, okay? Organic farming and conventional farming, okay? Method A and method B, okay, now. So the difference between this problem and the other problem is, what's the difference? This is example 2. Just now we talked about example 1. What is the difference between example 1 here and example 2?
Different number of samples from A and B.
Oh, perfect. Good. Okay, you can see here, right? Even though, yeah, like how many, yeah, this is actually the points for data 1, method A, right? Okay, so what is the sample size? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now we can say N A is 11 and N B is 12, right? Because it's just plus 1. Okay. So that's, yeah, one of the difference. And this one is more like just now we just have 4, the sample size, which is much smaller. So this one is more. And if you want to compare with dependent samples, this is from the different sample size over here, you actually can automatically know that these two samples are independent. They are not matched. Because when we are analyzing the problems under sign test and Wilcoxon sign rank test, you can see that the sample size, the size of the data that we are comparing is always equal because they are matched one by one, right? If there are 12 points to be compared, right? There must be 12. It cannot be like this. Yeah? So this is an indication that these data, these data are independent data. Okay, that's one of the indications, right? You cannot say these are matched because they are different number of size of the sample. Okay, back to this problem. So from here, you can see that the sample size is 11 and 12. Okay, one of the things also when you analyze the data, let's say, you want to apply it in your research, you see the data is less than 25, right? So obviously, you know that this type of data is non-parametric data. Okay. And also just now you see that they are not similar in terms of the size of the sample. So they are independent data. So that's how you analyze the data before you go into the test. Okay. So this is non-parametric, they are independent data. So because of that independent data, and there are only 2 samples that you are analyzing. So that's how you can know what kind of test is suitable, which is actually Mann Whitney. That's how you can decide which test you want. It's not suitable to use sign test. It's not suitable to use Wilcoxon sign rank test. Okay, because these are independent data. Okay, so back to here. So how we want to analyze? Just apply all the steps that we discussed just now, from developing the hypothesis and then until making conclusions. But you have to take note on the test or the Mann Whitney. Okay. So the alpha is given 5%. That is the alpha. Right. So since this one is a bit bigger, the sample size, 11 and 12, and you have to combine the data when you rank it. So it means that you need to be extra careful because you might miss the value. Sometimes some of the values should be ranked earlier, but you miss it out. So that's why you have to be careful with the ranking. Okay. So now let's have a look at the data. You have to check once you rank it. Okay, just go through again whether the ranks are correct or not, in order to make sure that you don't do any mistakes. Okay, so if this is the data given, this is the data. So let's have a look. So you just have to find out what is the lowest, what is the highest, and you have to rank it. So this is the one here is the ranks. Okay. So the lowest value is 1.1, right? So that's why it is ranked as number 1, the lowest. Okay. Then you go directly to rank number 2, which is 1.15. So after 1.1, 1.15. So that's why you name it as 2. And then 3 is this one, right? This is. Okay, so if you were to analyze by yourself, you have to be careful. You have to check very carefully. Yeah. Like this one is given to you. This is a solution actually. So number 3 and so on. 4. Okay. Is there any values that are similar? Right, let's check. Right, okay. So that's how you got from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dia tak ada type rank lah. There's no type ranks. Because all are not similar. Okay, understand how to rank? Combine the samples, rank it from the lowest to the highest. That's how you got this, the one in the bracket here. Okay, and then, before that, hypothesis. Hypothesis this is the step 1. Okay. Same thing lah, mu A equal to mu B for this one. Okay, so now, the question says that test that there is no difference between the yield distribution. Okay, this is an indication that it is a two-tailed test. So that will determine your alternative hypothesis to be this way. Okay. So it's a two-tailed test. Right. So after you rank it, and you have to find the sum of ranks. Yeah. The sum of ranks means the sum of rank A, 11 plus 22 plus 3 until 4. Okay, that's how you got this 1, 2, 3. And the same thing for the method B, the sum of the ranks, 20 plus 21 plus 18 plus 13 until 23. That's how you got 1, 5, 3. Okay, and then you have to find the UA and UB, right? Using the same formula. So you have to find this one first. That's why you substitute this value into here. This one over here, right? Okay, and A is 11 and B is 12. So you got UA as 57 and 75. So the U because it's a two-sided, is the minimum value of UA and UB, minimum of 57 and 75. So it is 57, the U value. Okay, and then you have to find from the table, the CV, right? Okay, now the value of NA is 11 and B is 12, and the alpha is 0.05, and it is two tell tests. Okay, let's have a look at the table, how to find it. Okay, go back to the table. Is two tell and alpha is 0.05. Okay, so this one, right, this is actually the condition. So you have to use B, the table, yeah, the B table. So N1 just now is 11 and 12. N1 is 11 and 12 is, and N2 is 12, sorry. Okay, so this is the value that you have to refer. So this is the value, 33, the CV. Okay, so go back to your workout. So CV is 33. Okay, so you compare the 57 and 33. So 57 is greater than 33. So you have to do not reject or accept the null hypothesis. Okay, accept the null hypothesis. So conclusion is that at 5% of level of significance, there is no difference between the yield of organic and conventional farming methods. So you see the word here is insufficient to say that they are different. But actually you can also say that there is no difference between the organic and conventional farming. If you are learning in this kind of style, you can just go directly say that there is no difference because you accept the null hypothesis. There is no difference for the organic and conventional farming methods, which is A and B. So yeah, you have to go specific into the case. This case denotes A as the organic and B as the conventional. So step back, what is A and B? Okay, guys. So those are the two examples. Okay, and the basic things that you have to know again is about using the Mann-Whitney test and how to use the table. That's very important. Yeah, so all the 9 steps here that you have to know how to use it. Okay, any question before we wrap up?
Doctor, may I ask, so what is the U value actually? What is the definition of the U value?
The U value is yeah, it's defined as that one actually. I mean, is the parameter given by people to compare or as a basis for comparison. If you ask me, I also do not know why they call it U, why this will concern has certain parameters, because that is based on their theories, you know, like when people invented E equal to mc square, why m is there? Because of course you can say that energy depends on mass, but the basic behind it, before it, I do not know, I can't explain it, sorry.
So it just exists because the formula, that's all, is it?
No, the thing is, like I said, this test is actually invented based on their observation. So they define this kind of U, yeah, they define it, yeah, as a basis of comparison. So yeah, I have no answer, no absolute answer for that. Why it is U, and yeah, sorry. Is it okay?
All right, thank you, doctor.
Okay.
So it's not like S that has the central tendency to use to determine because in the Wilcoxon test, S means the central tendency used to determine the dispersion of the data. So U here is just there. It's
It's
just
just
there.
a parameter. It's just a parameter. Like they create this formula, right?
All right.
So it's yeah, I don't know why they come up with this formula. I don't have any answer for that.
I see. Right. Thank you, doctor.
Okay. Um, any questions? Some of you asked in Telegram, but sometimes I'm not really aware of the questions, and I might respond it a bit later. Maybe it's like weekends I will respond it. So I'm so sorry if my response is quite late because yeah, I'm not really aware of the notification. So sorry for that. So if you have any questions, you can ask yeah, you can please allow some time for me to respond. Sorry for the delay. Okay. Right. So some of you asked the answers for sorry, answer for sign test, right? Homework one. Okay, I have here. Okay, sign test homework one. I suppose you already know how to use it, how to use the test, right? So the answer is P is equal to 0.0192. Decision is to accept the alternative hypothesis, and the conclusion is the mu of the post course is greater than the mu of the pre-course, which says that the course improved the cadet score. This is what I said just now. That's the answer. Do you get the same answer? Any question on this? I will post this later on ELIP, the answer for homework one. Okay, homework two is about comparison between lawyer, the mean of income, is it? The test, the lawyer and the architect. Right, so that's how you write the hypothesis. And because it's stated, I think, in the question, test whether the the salary, is it the salary? The salary of architect greater than the lawyer. So that's why I come up with this hypothesis, the alternative hypothesis. Okay, so the decision is to accept the alternative hypothesis. And the conclusion, it says that the architect tend to have larger average weekly income. Yeah, because it's not similar. So that's the conclusion. You got the same answer? The P is 0.0155. Any question, guys? You're so quiet. I don't know whether I'm talking alone or are you still with me or not? Okay, that's the answer for the sign test. The homework, homework 1 and 2. Do you manage to find practice problems by yourself? Like for Will Concern, I don't give any homework for you, but I expect you guys to Google the practices. There are so many questions on internet, right? And they give the answers as well. You can refer to to the websites that have the practices. Yeah. Right. So, and for the Ben Whitney, I don't have any exercises as well. Maybe if let's say I try to find some problems, I will post on Elite, okay, for you to just practice by yourself. Okay, so if there's no more question, then that's it for today. Thank you very much for your attendance. I'll already uploaded the lecture notes and also the table, the Mann Whitney table on Elite. Okay, please have a look at it. So, any more attendance? Second attendance. Okay. So if you have scan, yeah, you are free to go. Have a nice day. Selamat berpuasa for all Muslims. Right. Stay safe, and I'll see you guys next week, inshallah.
Ya, dokter.
Thank you, dokter.
Right. Welcome.
Thank you, doctor.
Okay. Welcome.
Dokter, selamat berpuasa.
Okay. You too.
Thank you.
Thank you, dokter. Have a nice day.
You too. You too.
Need manual attendance, doctor.
Attendance. What?
I cannot scan.
Okay. What's your name?
Muhammad Zaki.
Myself. Okay. Done.
Okay, thank you, doctor.
All right. Is Fanny around? Fanny.
Doctor,
Yes.
I forgot to ask question just now. How do we find the total again? The total.
It's based
How do we know
on
it is total? Yeah.
based on the question. Based on the question. Okay. If I show you again, sorry. Here. Hold on.
I also have the question how to determine
Yes.
one tail and two tail.
How to determine?
One tail and two tail.
Okay.
Same question.
Right. So it depends on the question. Okay. If let's say we see the first example here, right? The question. Okay. Go back to the question. The original question. The bacteria counts per unit volume. So and so. Okay. So the key points is here. To determine, it is of interest to determine whether one culture has a significant count than the other. So means that we want to know whether the culture A is different or not than culture B. I mean, it doesn't mention, yeah, but it says that in general, whether the two cultures have a difference or not. Okay, that is the only hint, isn't it? Correct? So that leads us to construct. Of course, we know that the null hypothesis is it should be equal, right? So the alternative hypothesis, you can write not equal. Okay, so because we do not, it is not stated that we want to test whether the mu A is greater than mu B or not. So this is the general form. It is not equal. Okay, so I give you an example with the previous one that has mentioned about which one is bigger than the other. Where is it? Like this one. It applies actually for all the tests. It is stated in the problem. Okay, like this one. The problem is to find whether evaluator X gives higher evaluation than evaluator Y. So it is mentioned specifically that sort of situation. So this we can put it mu X given greater than mu Y. So means that this one is one-sided test. Okay, if let's say the question is not saying like this, but the problem is to find whether there is a difference between evaluator X and Y, just like that. So in that case, you have to put mu X is not equal to mu Y. Understand?
Understand.
So it depends on the problem. It depends on the problem. Okay. So you have to read the problem carefully. And this is actually the keyword lah, actually the keyword that will determine whether your test is one tile or two tile. Okay. So this one, if you apply two tile here, that is wrong because it's mentioned in the question, right? So back to the Mann Whitney just now. So this one, yeah, whether one culture has a significant count than the other. So it's not stated whether A is greater than B or B greater than A. So you have to apply this symbol, which means that this is two tile. Okay, and same thing goes to example 2 just now. So see, this one is the keyword here. To test that there is no difference between the yield distribution. So it means that it is just a general statement that you want to check whether there is a difference or not between method A and method B. So in this case, that's why you have to apply this symbol, which means that it is two tile test. Okay? Understand? Siapa tanya tadi?
Doctor.
Mark.
Yeah, understand, Doctor. Thank you, Doctor.
Okay. Another person, just now, Nadia. You asked me just.
Sekejap.
Another question? Other question?
Alright. So in the conclusion, kalau yang one-sided test tu sama ada dia higher or less, lepas tu yang two-sided tu not equal to. Doktor?
Yes,
Is it?
yes.
Oh, okay. Okay, thank you, Doktor.
Okay, welcome.
Thank you, Doctor.
All right, welcome.